Thank you. So my name is Lars. Thank you very much. I'm an engineer. I work with architects to design buildings, and I've been, improving how we waste energy in buildings for decades. I want to talk to you about, a little bit about the past, but also predicting the future, and how we have to see buildings as not being islands, but being parts of the city. I like this chart because it shows how far we've come, how much we've learned. This is for Denmark. I'm from Copenhagen. And in Denmark, we have the building regulations coming out every 5 or 10 years. We've had first time energy was regulated was in 1961, so like 50 years ago. Before that, there was no requirements as to how much energy a building could use. But since then, and especially after the oil crisis in 1973, we've kind of put a lot of effort into trying to save energy. And the government has pushed us as engineers and architects to try and do better and better and better. And we've learned a lot. We've developed new design methods. We've developed new building components, new insulation materials, and so on. So we have today a much better understanding of where energy goes. And we also know how much we can achieve in the future. So we have already decided now what is the future requirements. And again, this is for Denmark. What is it in 2015 and in 2020? But then it's very tempting to start talking about the energy neutral house or the zero carbon house. And we're already building what we call passive houses. So buildings that consume very, very little energy. But there is a limit because it costs a lot of money to design a building to use no energy. And actually, a building has to use energy, but what we do then is to design buildings that also produce the energy that it consumes itself. And here are two recent examples. One from Bahrain, where the World Trade Center has, we've put up wind turbines between the two towers. And it's a nice idea, and we did it just like the client wanted. But to be honest, the cost of these 3 wind turbines and these were 36 kilowatt wind turbines, they were the same as it would have cost to put up 3 megawatt turbines just next to the building. So actually, you could get 100 times more energy by not integrating the energy production system into the buildings. And secondly, we've got a kindergarten in Denmark where we've, again, because the client wanted us to build this zero energy building. So we've put PVs, photovoltaics, all over the roof to produce the energy that we need inside the building for the lighting, for the appliances, and so on. But again, the cost of doing that, of producing energy in this way, is much more than it would have been to put or to buy the power from the power grid. So we've been looking also at larger neighborhoods and where buildings can benefit from each other. This is in central Copenhagen. Carlsberg is moving out, and they are leaving what was former the brewery site. They're leaving that behind, and this is now being developed. We've looked at how much it would take to create this carbon neutral neighborhood, which Carlsberg actually wanted us to do. And here are the comparison between putting up photovoltaics on every rooftop as one option, putting up micro turbines, these small things that you can actually also put on the rooftops, as a second option, and comparing it with putting up 2 pieces of offshore wind turbines. And as you can see, the cost of producing local power is like 5 or 6 times the cost of producing centrally. And it's so this is a central production. We put up wind turbines in a wind farm just outside of Copenhagen. And the cost of this is way below what a local production would cost. It's not only the investment cost in the first place, the capex, it's also the operational costs that are much lower. Because if you had to go out and maintain and inspect every rooftop facility, that would just cost millions of kroner. It's the same if you look at the heating. So the heating we use in Denmark to heat our buildings can be produced on solar hot water panels, and we can put those on every rooftop, every small rooftop. We can put them on only the larger rooftops, which means that we have to collaborate between the buildings, or we could just put them outside of the city on farmland and actually give a farmer the opportunity to get an extra income from his farmland in addition to what he already gets from farming. And that's much more sensible. And I'd like to just explain to you, where we are coming from and why we are then doing what we're doing today. This is the energy system that we have built throughout the 50s and 60s. We've built big power stations. We've transmitted the power from power stations to every building. But in the power station, there's already a huge loss. The fuel that we put in is like 100% energy, but then we lose like 70% in the production of power. And in the case of central power station, we lose all of that energy directly into the sea because we use cooling water to cool down the process. Now, also in the transmission process, we lose about 10%, and in the buildings, we have had in the past very inefficient lighting, very inefficient appliances, and so on. So what we are doing and what we have been doing for decades now is we've captured the heat that in the past went out to the ocean. We've captured that and we've fed it into the cities. And we built district heating networks, so use the heat to warm up the buildings. And so the heat loss or the energy loss is much less. Also, of course, we have increased efficiencies in lighting. We now have LED lights much more. We also have more efficient televisions and washing machines and so on. And the total energy system today is 70%. This is to compare with 3% only 20 years ago. So we are much better off, and if we look what the consequences are actually for the energy production system, here we have Denmark 30 years ago with a few central power stations, all the red dots, and we have the same map just 25 years later with a lot of decentralized power plants that those are CHP plants, so combined heat and power plants, that are feeding their waste heat into all the cities around the country. So this is how we have achieved energy efficiency. But in the future, we have a lot more heat sources than just the power plants. We have wind turbines already today that accounts for like 30% of the power production in the country. We have biogas, we have PV solar, and we have hot water solar. We have hydropower because we are connected to Sweden and Norway, and we have biogas and biomass and so on. So there's a lot of various sources of energy production. We need some of that to be converted before we can send it to the end users, and we also need storage because some of wind turbines is sometimes blowing during night when the power is not needed. So if we can store power, and sometimes in the form of heat, that makes the whole system much more efficient. So this is a smart grid thinking that we have already simulated, and we know how it's going to develop into the future. And we've connected, of course, every power station, every city, every house in the country to the grid. But we also connect Denmark to Germany, and Denmark to Sweden, and Denmark to Norway, so that when one country produces too much because of the renewable sources like heat and solar, it can export and balance the heat and demand with the supply and demand with the neighboring countries. And so in the future, this is Denmark entire building stock, and this is how it is heated throughout until 2050. We can see that we keep expanding the blue, which is the district heating systems, and we have phased out all oil already. We have introduced natural gas 20 years ago as a cleaner alternative to oil, but this is also being phased out now for the next 10-15 years. And we are then, for homes that are not connected to district heating system, we are planning on using heat pumps that moves heat from, for example, the ground next to the building and move that into the building. The black line is the CO2 emissions, because in this process we transform the whole energy system from a carbon-based system, which was like in 1980, to a renewable energy-based system in 2050. So the carbon emissions in 2050 will be almost zero. If we look at the fuels that we use, it used to be coal, oil, and waste. Waste is also something we produce, that we will keep using, but in addition to that, we have a lot of biomass, a lot of wind and solar power, so we can achieve zero carbon emissions for the whole of the country in 2050. So coming back to this, the idea of a building that produces its own power and is considered a energy neutral building, that idea is not a very sustainable idea. The idea is much more to buy the energy from the grid, whether it's heat or power. You can buy it much more, and you can produce it much more efficiently, and buy it when it's cheapest. Thank you very much.